Satellites have a common problem, and that is they're always power starved. No matter where you are, there's not enough power. And conventional solar power comes from rigid deployable arrays, typically with cover glass. They're somewhat fragile, easily damaged during packaging, and it's difficult to get a lot of power in a small spacecraft, which is the current generation of CubeSats and ultra-small spacecraft. What we're doing in this test is we're demonstrating the ability to take next generation, very flexible solar arrays, fold them, package them into a very small volume, and deploy them once they're in space so that you can get a large surface area and generate a lot of power from a small volume.
The way this all got started was we were working with several companies on very thin film, lightweight solar cells. And these are very different than the solar cells that are used in space applications today, in that they're very flexible, they're very light, and they're mountable on a variety of substrates, including aluminum or Kapton. And we were thinking about structures that we could mount them on, and we realized that inflatable structures were the perfect mounting structures for those, and that they gave us a very rigid structure that would hold the lightweight array and would also provide very small storage volume for the array that you end up with. The unit you see came from a concept study that we did for a microsat that would implement a telescope application. And so we took the concept design that we had and actually built a test article out of it. The silver substrate pieces that you see aren't printed with solar arrays, but we had one actual solar cell that we attached to the pedal, instrumented, and we did a flash test of it in the beginning, and we wrapped it up for deployment. Now we've done the deployment, and we'll do another test to assure that the deployment hasn't damaged it in any way. This will achieve TRL4.
There are a lot of applications for this technology. We envision that you could use this inflatable or deployable solar array system, everything from CubeSats, which are the very small 10 centimeter by 10 centimeter spacecraft, which are typically very, very power limited. Something like this could be packaged in about a third of the volume and inflate to something this size, providing unheard of power for small sats, primarily in low Earth orbit. You could also take this technology and use it for human exploration in deep space and deploy incredibly large, think size of this room or bigger arrays packaged into something smaller than the table. The next steps for the technology are to take this demonstration, which we believe has shown the viability of this at technology readiness level 4, and start looking at how you adapt it for actual space environment deployment.